Introduction.
Hey, look this picture. A Greek mathematician performing a geometric construction with a compass from the School of Athens by Raphael. Do you know how does geometry originate? It appears to have originated from the need for measuring land. You know, today our teacher is going to teach us a different form of geometry. What is that? Euclidean geometry. It is a mathematical system attributed to the Alexandrian Greek mathematician Euclid, which he described in his textbook. Come, let's go to the class and learn.
Objectives. At the end of this lesson, you'll be able to understand Euclid's definitions, identify various axioms and postulates, understand equivalent versions of Euclid's fifth postulate, solve examples related to Euclid's axioms and postulates. Introduction to Euclid. Euclid from approximately 325 to 265 BC is called the father of geometry, not because he invented it, but because his book Elements is the oldest geometry text we have in the Western world today. Euclid believed each part of geometry should be based on previously proven parts. However, something has to be the starting point, and he proposed 4 undefined terms and 5 basic axioms. The rest of Euclidean geometry is based upon these basic building blocks. Euclid's definition. Euclid divided the elements into 13 chapters, each called a book. These books is influenced the whole world's understanding of geometry for generations to come. He began his exposition by listing 23 definitions in Book 1 of the Elements. A few of them are: a point is that which has no part, a line is breadth less length, the ends of a line are points, a straight line is a line which lies evenly with the points on itself, a surface is that which has length and breadth only, the edges of a surface are lines, a plane surface is a surface which lies evenly with the straight lines on itself. Point to remember. A point, a line, and a plane are concepts only, and these terms are taken as undefined. Axioms. Euclid describes axioms and postulates, which we will discuss here. The axioms or common notions are about relationships. What does equal mean? How do you add or subtract things? And so on. These are assumptions which are self-evident truths. Some of Euclid's axioms or common notions are: 1. Things which are equal to the same thing are equal to one another. 2. If equals are added to equals, the wholes are equal. 3. If equals are subtracted from equals, the remainders are equal. Things which coincide with one another are equal to one another. 5. The whole is greater than the part. 6. Things which are double of the same things are equal to one another. 7. Things which are halves of the same things are equal to one another. Postulates. The postulates talk about straight lines, circles, right angles, and parallel lines. These have been defined already. Euclid's postulates are 5 in number. First postulate is: a straight line may be drawn from any one point to any other point. Postulate second is: a terminated line can be produced indefinitely. Other postulates. Other postulates are: Postulate 3. A circle can be drawn with any center and any radius. Postulate 4. All right angles are equal to one another. And Postulate 5 is: if a straight line falling on two straight lines makes the interior angles on the same side of it, taken together, less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. Theorems or propositions. Theorems are the statements which are proved using axioms, previously proved statements, and deductive reasonings. Following the definitions, postulates, and common notions, there are 48 propositions. Each of these propositions includes a statement followed by a proof of the statement. Each statement of the proof is logically justified by a definition, postulate, common notion, or an earlier proposition that has already been proven. Some of the propositions are constructions. Theorem. Two distinct lines cannot have more than one point in common. Given two distinct lines L and M, we have to prove that lines L and M have only one point P in common. Proof. We shall prove it by contradiction. Let us consider that two lines intersect in two distinct points P and Q. Thus, we see that the two lines L and M pass through two distinct points P and Q. But this assumption clashes with the axiom. Given two distinct points, there is a unique line that passes through them. Hence, our assumption is wrong that the two lines can pass through two distinct points is wrong. Hence, two distinct lines cannot have more than one point in common. Equivalent versions of Euclid's fifth postulate. We have two equivalent versions of Euclid's fifth postulate. The first one is play fair axiom. This says that through a given point, not on the line, one and only one line can be drawn parallel to a given line. And the other one is two distinct intersecting lines cannot be parallel to the same line. All the attempts to prove Euclid's fifth postulate using the first four postulates failed, but they led to the discovery of several other geometries called non-Euclidean geometries. Example. Let's solve an example now. Prove that an equilateral triangle can be constructed on any given line segment. Draw a line segment, say PQ. Using Euclid's postulate 3, which says that a circle can be drawn with any center and any radius, we will draw a circle with center P and radius PQ. Again, we draw another circle with center Q and radius QP. The two circles meet at a point, say R. Join P to R and Q to R. Now in triangle PQR, PQ is equal to PR and PQ is equal to QR. So, by axiom 4, things which are double of the same things are equal to one another. We get PQ as QR, which is equal to PR. Hence, triangle PQR is an equilateral triangle. Did you know? Little is known about Euclid, the author of the Elements. He taught and wrote at the museum and library at Alexandria, which was founded by Ptolemy I. Euclid is said to have said to the first Ptolemy, who inquired if there was a shorter way to learn geometry than the Elements. The Elements. Basic facts. Written about 2300 years ago. No copies extant. Many new editions were issued. Earlier copy dates from 888 AD in Oxford. Style. No examples, no motivations, no calculations, no witty remarks, no introduction, no preamble, nothing but theorems and their proofs. Summary. Let us summarize what we have learned. The terms point, a line, and a plane are now taken as undefined. Axioms or postulates are the assumptions which are obvious universal truths. They are not proved. Theorems are statements which are proved using definitions, axioms, previously proved statements, and deductive reasoning. There are two versions of Euclid's fifth postulate. All the attempts to prove Euclid's fifth postulate using the first four postulates failed, but they led to the discovery of several other geometries called non-Euclidean geometry.